Alright, hello everyone. My name is Joe Scorsone, channel is called Ethernet Wink, and today I'm going to be bringing you guys another Quant Connect coding tutorial in regards to algorithmic trading. In today's episode, what we're going to look at is two different ways to calculate market entropy. Now, it is really useful to be able to calculate market entropy because in order flow strategies, it could work in tandem really well with determining whether or not to be in a trend or regression mode. Trend mode being when the market is going up and we have low entropy, and regression being when the market is going down and we have a high entropy. This could be very useful for that. So I'm going to get right into it because my last videos have been a little bit longer than I would have liked. I already have some code here. Very simple stuff. We're just adding an object we want to calculate entropy on. In this case, it's S&P 500 futures. And I have it on resolution daily just so when we plot it, it can look pretty. But if you're going to use it in an order flow strategy, you probably want minutely data, but that's whatever. We'll just plot it. I'm just doing this so I can plot it. But yeah, we're going to have the last 30 prices, the last 30 days in this case. And we're going to make a rolling window, and we're going to store quote bars. Okay, we're going to have it of size self.lookback, so that comes into play in a different way to calculate it. The second way I'm going to show you guys. So yeah, rolling window of quote bars. In our onData method, we're checking if the symbol has data or not, and we're adding the quote bars to our rolling window, and we're checking if the rolling window is ready, and then we're just plotting it. We're not actually going to be taking trades. So let's get into it. We're just going to do this entropy function right here and then plot it. So what is the first thing that we need to do? Well, the first thing we need to do is we need to get this rolling window into a Python object. So honestly, something that we could do is we could probably put this up here in initialize, but just so that we don't make a new list every time we call this function, but we're just going to leave it like this for now, just so that way it's easy to read. So we're just going to say variable stock prices equals bar.close for bar in self.price window. What does this do? Because rolling window is not a Python list, we can't iterate through it the same way we could a Python list. Actually, I think we could, but this just makes it very intuitive, and also now we can control what we want to calculate entropy on without changing other things about how our rolling window behaves. Let's say we want the open, the high, the low, whatever, we can change it all right there. All right now. So, and also when we do math with it, it just makes it all a little bit easier. All right, so now we actually need to import NumPy. So import NumPy as NP. I have math in there as well. I don't know if it matters. I don't think so. But first thing we got to do is we have to calculate the mean price of our list. So the mean, and we're going to say np.mean of stock prices. Okay. Next, we need to calculate standard deviation. So std price equals numpy.std, and we're going to pass it stock prices as well. There we go. Okay. Now what we need to do is we actually need to calculate entropy. And we're going to try to normalize it, but it doesn't work that well because it's not between 0 and 1. And this particular one spits it out in scientific notation. But I want to play around with it a little bit with you guys right here and see if we can get it to do it without it printing it in scientific notation. But before that, we got to actually calculate it. So we're gonna initialize our variable. It's going to store normalized entropy. So normalize entropy. And just to make sure I spelled it right, in case I have to copy and paste anything that's my reference, I did not spell it right. And we're just going to set it equal to 0 for now. I almost added a semicolon. I've been coding in Java after college, even though I don't like Java, but whatever. Next thing we're going to do is we're going to iterate through. So we're going to say for price in stock prices. Now, we're going to say our normalized entropy plus equals, just to keep this quick, and we're going to say caps lock on. We're going to say price minus mean price over standard deviation price. Next, out of the for loop, this is our normalization. We're going to say normalize entropy divided equals self.lookback, the length of our prices. Okay, and now we're going to return it. But this particular math returns a number in scientific notation with like 7 decimals. So we're going to multiply it by a 1 with, I think that's either 7 or 9 zeros in front of it. But this will work, so we're going to build and backtest it. And then I want to see what happens if we don't put it over self.lookback. So, oh yeah, let me go over how to plot it again. This line right here is all you need to plot. You got to name your graph, you got to name your axis, and then say what you're putting on it. So we're just going to pass the function. And then when it comes in here, you'll have another chart right there. So you just select entropy. I already have it right here. You make it nice and big. And here you go. Actually, yeah, no, it's not between 1 and 0. You see that's a 3. But here we go. Here's the entropy of the stock market over time. And this is kind of what we're looking for. You see, this is a pretty good one. Right there, we have a pretty, can I like zoom in? I can. Perfect. You see how we have a bit of an uptrend right here? This is a real cherry picking scenario. We've got an uptrend right here. It starts moving, we get higher, and entropy dips a little bit lower, and then as soon as the market dips a little bit, entropy gets higher. And it has kind of an inverse correlation. That's kind of what you'd be looking for in an order flow strategy. So that's how it would work in this one. And I want to see what will happen if I do that. All right, let's see what we get. Yeah, scientific notation to 12. Yeah, it's a little ridiculous, but it does work. You just have to manipulate it a little bit. If anybody is really good at Python and knows how you would be able to kind of suppress the scientific notation in this, feel free to comment, feel free to leave it somewhere, because I know I would enjoy that, and I believe other people would as well. Next, we're going to go into the second way. I'm going to show you guys how to calculate entropy. So I'm just getting my other reference up here. And this way, it's a bit different, but it still works. This is kind of the Shannon entropy approach, and it's a little bit different. We're going to stick with the bar.close here and just use this list, because in this code I have in my reference, I used a rolling window with just the closing prices. But we're going to keep this little ease of use going right now. So what else do we need to use for the second way of calculating entropy? Because again, there's no right way to do it. There's no wrong way to do it. It's going to get determined when you actually test something and you notice, okay, when I do it like this, I have better returns and a higher Sharpe ratio. That's all you would have to look for. And I'm just trying to give you guys 2 ways that you could go about doing that. So in this function, the second thing that we're going to need to define is a dictionary. And we're going to call that dictionary price counts. Next, we're going to say for price in our stock prices, what are we going to do? We're going to say price counts, the key of price equals price counts dot get price, and if there's nothing there, 0. And we're going to add 1 to that. If nobody knows what .get does, what it does is it'll either get the data in here, because this word could be anything. It could be I, it could be J, N, W, price, it could be whatever you want. But it represents what is in stock prices at that index. So we're either going to get the price or we're not, and we're going to put 0 in there. It's kind of an exception handling thing and to combat errors. And also it's just a kind of more formal way to do it, you know what I mean? And we're going to add 1 to it at the end. So next we need to initialize our entropy variable. So we're going to say entropy equals 0. And then we're going to say for price count in price counts dot items. Just remember it's a dictionary. We're going to say probability because we're calculating entropy, so we might as well name these variables as something relevant. I don't think I spelled that right. I'm a programmer, not a. Oh, I did. I'm an algo trader, not a writer. Anyway, I'm going to say probability equals count over self dot look back. That's why it gets a little convenient to make this a variable, like I was saying in the beginning. So we're going to do that, and then we're going to say entropy minus equals probability times math.log probability. You could use NumPy, you could use whatever. If I could spell math.log probability 2. That's the base that we're going to use. So it's the log base 2 probability. Next, we're going to actually normalize it, so we have to get the max entropy. Oh, I just got an idea now on how we could get the other one to work. We'll try that right after this. We'll say max entropy equals math.log of how many prices are in there. So we're going to say self.look back again. Next, we're going to do is we're going to say normalized entropy equals entropy over max entropy. And then normalized entropy equals normalized entropy minus 1. If you want it between 0 and 1, if you want it between 1 and 2, then keep it like that, preference. And then we're just going to return it. Okay. And let's build and backtest and see what we get. Alright, there we go. And yeah, this one looks a little funky. I'm not sure why it looks like that, and it does change between hourly and daily. Of course, again, if you're going to use this in the context where I would, like an order, where I do, like an order flow strategy, you would have this on minutely. And we just can't plot that over a whole year like this. It just, QuantConnect kind of freaks out. Yeah, even this one doesn't finish it the whole way. But we see, it does its thing. We want to see what happens here. Yeah, big dip as we get a little pop in the market, and then it kind of holds the higher one as we keep going. Is what it is. We're going to put this in now. So yeah, those are the two ways that we're going to calculate, that I would calculate entropy. And there's just two ways that you could. But now, while we're here, while I have this idea, what I want to do is I'm going to come back in here and copy and paste this code back into the file because I want to try something. Because we have normalized entropy equal that over self times self.lookback. However, the way that it's calculated in this one, which is just what I'll try and do right here, is we have a max entropy form variable. So max entropy equals math, essentially the natural log of lookback. Math.log self.lookback. And then we're going to say normalized entropy equals entropy. Actually, no, we have to say normalized entropy over max entropy. And so now, actually, just to make this not confusing, let's do it like that. Yeah. And then, yeah, and maybe we'll have to subtract 1 from it. I just want to see if this will work, because this is the first time I'm actually doing those two formulas like back to back like that, just for this video. I never noticed that that could even happen. Nope, that made it worse. Scientific notation to 13. Okay. Well, bottom line for this video, you now know two ways to calculate entropy. One of them is in scientific notation and it looks terrible before you mess with it. The other one looks a little funky, but they all kind of work the same way and work well with minutely data, with any data really. and it could definitely be useful for your trading. The way that I would check if entropy is high or low is I would make a moving average, a custom moving average, and set it and give it the values of this and just make sure that it's full before we start trading. And then say if the actual value is greater than or less than the moving average value. That's what I do, but of course do whatever you would like. I hope that you guys found value in this video. I know that it was a little all over the place at times with me trying different things and getting random ideas in this video. But I hope that nonetheless you guys find value in it and that you can implement things like this in your own trading. The next video I think I'm going to do is a video very similar to this about calculating the Hurst exponent. But yeah, that'll be all for now. My name is Joseph Orson, channel is called Ethernet Wink. Feel free to like and subscribe, I would really appreciate it. And I'll see you guys all in the next video.